So hello everyone, welcome to this new video, and today we are going to solve the daily LeetCode problem. So this is the problem 966, and the name of the problem is Vowel Spellchecker. Okay, so the today's date is 14th of August 2025, and it is a medium level problem. So I hope you have tried this problem and you are not able to solve this. So let's try solving this problem, and let's tell you how should we approach this problem. Okay, so first let's see what the problem is saying. So actually we are given a word list, okay, which is containing some strings, some words, okay. Then we are given a query word, and we have to convert this query word into some correct word using some operations or something, okay. So let's see what are the operations. For example, our query word is yellow with a O, bigger O, okay. Then we have to search the word list for the correct word. So what will be correct word for this? So correct word for this is yellow, because these two strings are similar. The only difference is that O is bigger and O is smaller. So in this way we can find the word yellow in the word list and return. Other thing that you can see is that if the word is yellow and the word present in the word list is also yellow but y is bigger, you will just return what is present in the word list. And similarly, if both words are same in your query in your word list, you will just return the word in the word list. So basically this is the way you have to convert your query word into the correct word, okay. Other than that, if there is no similar word present in the word list, one other operation that you can do is you can just check if there is similar word which only differ by vowels. For example, your query word is YOLO, but the word that present in word list is yellow, okay. So these two strings are only varying with these two letters, that is the E, here it is O, okay. So it is varying by vowels. So if the string varies by vowels, you can just return the simple that the word present in the word list, that is yellow, okay, with the O bigger, okay. Other than that, if nothing works, if you are not able to find the similar word for our query out in the word list, you just have to return an empty string as a correct word, okay. So that's basically what our question is trying to say. Now let's see what are the rules that we have to follow, okay. So basically these are the you can say priority we have to follow, okay. So you are given with a query, okay, query, and you have to check if there is similar query present the in the word list or not. So if the similar query is present in the word list, you just have to return the word in the word list, okay. If this is the topmost priority, if other than that, if the exact same string is not present in the word list, what you have to do, you have to check the similar substrings which only differ by capitalization. The case we saw here, okay. So we have, this is the second priority. If this is also not present in the word list, what you have to do, you have to find the similar words which only differ by the vowels, that is this case, okay. So these are the three conditions. Other than that, you have to return the empty string. One thing that you have to remember is that we have to return the first such match that is found. You have to remember that thing, okay. So now what we are doing in this question, so basically the solution is present in front of your eyes, you have to just see it. You are given three conditions, okay. So based on that, we are making three maps. So three maps means one set and two maps, okay. So what will these, this is a set, let me keep my screen up. So this is the set we are taking, and these two are the unordered maps, okay, that we are taking, okay. So what these set and maps are doing, okay. So exact map will basically contain all the strings in the word list. So you must be thinking why we are storing this. So this is basically to check in the starting whether our query is present in this exact list or not. If it is already present in this exact, you can just return the word directly as your correct word, okay. That's a simple first rule that we studied, okay. So other than that, we have made a lower map named unordered map. So what is this doing, okay, let me show you. This is basically storing the lowercase version of all these strings. For example, the lowercase of this string is kite, okay. Then it is saying kite, and corresponding to it, it is its value is for this key is the string exact string, okay. and it is string the it is storing the first string that is coming. Okay, so that's the rule that we studied. We have to use the first such map, so that is storing the same string that is present in the word list in our lower map corresponding to that lowercase string. Okay, so let's go to the other kite. The lowercase version for this is also kite. Okay, so we are storing this kite. We can store this kit in this, but there is a value already stored in this value, so we will go on to the next. So the lowercase version of this is har. Okay, and we will store this har value corresponding to this string. Okay, so now if we come to the last value, its lowercase version will also be har, but there is also a value present corresponding to this value, so we will skip this. Okay, other than that, we have made another map. So what this map is doing, so basically in this we are basically considering the vowels in the string as a star. So basically we are making a generalized equation, generalized form. Sorry, we are making a generalized form, which by which we can compare our query. Okay, so that we can compare our query to this generalized string and find out if this third case is satisfying or not. So let me show you how what this is happening. So we are basically given a query, a list, a vector of strings named queries, which has basically too many queries, and we have to find correct words for these queries and return the corresponding vector. So let's see what is happening. So let's take our first kite. So what is our first thing? First rule: check if there is an exact kite named string present in it or not. So basically there is a exact named kite present in it. So there is not we are not to check anywhere else for the correct word. So basically here it comes the exact word in its place. So let's come to the next. Okay, kite. Kite. Okay, so the word kit is already present in this, so this kit comes exactly here. Then the word is har. Har is also exactly present in this thing, so it will come exactly same in its place. Okay, sorry, I skipped a word. So basically this is also, oh sorry, I did a mistake, sorry. So basically kite is already present in the exact string. So So basically, what we are given a query. So query is a vector of strings in which contains too many queries, and we have to do these operations. We have to find correct word for all the queries. Okay. So let's see what we can do. So kite kite is the first letter, sorry, first string. So kite with all the small letters is already present in our exact string. So we do not have to check in other maps or something. We can direct return the correct word as kite. The other word is kite. Sorry, ki. Yes, kit. K is bigger. Okay. So this is not present in the exact set. Now we check in this. Okay. If there is this word is present here or not. Kit is not present here. Yes, it is present here. Actually, what we are comparing its lowercase kite. Okay, we will change it into the lowercase, and then we will compare it. Yes, it is present. So corresponding to this letter, we will return this value as a correct word. So this is the correct value for this letter. And this third string is already present in the exact. So we will directly return it. Same for here. Now let's check for this har. Okay. So if we convert it to a small har, it is not present in this. That's why we are checking in this. The small har is present in this. So we do not have to check the other. We will directly return har smaller. Okay. Now let's check hear. Okay, hear. Her is not present in exact. So what we will check, it is already in smaller though, so we do not have to change it into smaller. So basically we check in this. It is not present in this map. So then we will check in this. So we will change it to this form. What is this? Okay, but this is not present in this. So basically this string is not uh, this string cannot be converted into any correct word according to our rules. So here we will return an empty string. Okay. So that is the thing we have to do to all the queries. So let's see the code for our solution. It is a basically a tricky solution. So you can again watch the video and then come to the solution. So let's see what we are doing in our solution. So we are basically making a function, similar function that is converting, checking whether our character is vowel or not. So what is devowel doing? Devowel is basically to change a string into that generalized form. For example, here is lead code. Okay, so we can change this function will change this into L star star smaller t C star D star. Okay. So that's the function that is converting this into this. So basically what we are doing, we are taking the same string as into copying the string into a result array. Then we are traversing through the result array, and if we found any vowel, we are replacing it with star. Okay, and if any big letter is coming in the array, we are converting it into the smaller letter. Okay, so this is basically devowel. So now what we are doing, so this is the same thing. We are making a set, then we are making a map, two maps. One is lower map, one is vowel map. So what we are doing, so we are traversing through the word list. What is the word list? That contain all the type of words, etc. Okay, so then we are directly inserting all the words of the word list into the exact set, in this set, because we have to check, we have to use this letter now. Other than that, we are converting our word, copying our word into lower and converting this lower into the lowercase. Basically, it will convert the lowercase version of this word. Then we are storing this, checking whether this is already present in our lower map or not, and then we are inserting the lower map, lower into the lower map, and corresponding we are storing the word value corresponding to that in our map. Okay, and same we are doing, we are converting applying devo operation on our word, and we are storing the corresponding in the corresponding map. So basically these processes are we are doing to set up our set, one set and two maps. Okay, then what we are doing, let's check. So basically we are traversing through the query array, and this query is basically we are doing this on each query one by one. Okay, so what is the first step? We are basically checking if the query is already present in the result or not. If the query is already present in the our exact set, we'll uh, return the string as our correct word. Other than that, if this rule is not satisfied, what we will be doing, we will converting our query into lower letters, like we were doing in the example as I told you. Then these two lines are to convert our query into lower. Okay, then we are checking if the lower is already present. We will select the key is corresponding to that lower in our map, and we are choosing that as our correct word, and we are pushing this into the result, because at the end we have to return a vector result. Okay, so at the end, if both these rules are not being followed, what will we do? So we will be converting the query into that devolve form, like we are converting to star, vowel into stars, and converting uppercase into lowercase. Okay, so we will convert and check whether it is present in the vowel map, like the same we check in the vowel map. So we will check in the vowel map, and if it is present, we will return its corresponding key as the correct word. And if all the conditions are not satisfied, we will just push an empty string as a correct word into the result, and at the end we will return the result. So basically it is a very hard problem. So if you are not able to understand it properly, you can again and again and again watch this video, because if you try it again and again, you will eventually get what I'm trying to say. Okay, so if you have any doubt, you can ask in comment. So other than that, let's see the complexities. Okay, so basically we are making the using 3 hash map. So basically big of n is our space complexity, and if we check about the time complexity, So basically time complexity of our solution is big of basically we are traversing through all the word list and then the size of word. So basically our size time complexity is n square. Okay, but our constraints are very small for this problem, so this is very this is okay for it. Okay, so that's it for this problem. Thank you guys, thank you for watching this video. I will meet you in next video. Thank you.